Hello, we are Group 4, and our project is about NFT price prediction. Our goal is to predict the future price of several non-fungible tokens, that is NFT. First, we have to know what NFT is. It is a kind of cryptocurrency that represents the ownership of a digital asset. Besides its art value, it also has business value because it can be traded between owners. The novelty of our project lies in that, first of all, NFT itself is very new. It was first created in 2014. However, there is a huge market of the trading of NFTs. In 2021, it increased to more than $17 billion. Despite the huge market and trading volume, there is limited research about the NFT price prediction, especially using machine learning methods. The challenges we're facing is that first, there is insufficient historical data regarding the price of an NFT, and another is that the price fluctuations are really unpredictable. This is the system design of our program. First, we get the numerical data from OpenSea API. After pre-processing it, we form a numerical dataset, and then we feed them into 3 models, that is LSTM, bidirectional LSTM, and self-attention bidirectional LSTM. After training and adjusting the parameters, we came out with a model. Also, we collect text data from Tweet and Reddit, and also we use machine learning methods to form models. And finally, we could output the price prediction with visualizations.
And there are 2 data types in our project. One is numerical data, and we got the data from OpenSea API and nonfungible.com, and we selected these variables as the features, and also we sort the data by datetime and judge the rows with null values. And for the text data, we got the tweets from the Twitter API and do some pre-processing work and data clean to and feature transformation to pre-process the data.
We created a web page to show the data analysis result. We use serverless web hosting technology to host the web page so that the web page could be public access. And we have already shown this in our progress presentation. In this visualization part, we did a statistic on overall data and each variable, including calculating the amount of missing data, the distinct count, mean, maximum value for each variable, and plot the data distribution for each variable. In addition, we designed an interaction part. User could observe the corresponding between 2 variables by choosing variables for X and Y. And then for the methodology part, we use Google Colab to deploy our project, and we use Python, Keras, Pandas, Matplotlib, and so on. The goal is to predict the next day's NFT price based on the previous day's price. And we implemented 3 models. One is LSTM, one is bidirectional LSTM, and the last one is bidirectional LSTM with self-attention. It's worth to mention that in the attention variation, after doing literature survey related to attention-based LSTM model for financial time series data, based on those research about how to implement attention-based LSTM to stock price prediction, we applied a soft attention layer where we could apply the input with corresponding to train result. Then here is how we design our experiment. First, here is how we train the model. For the input, we treat the first n days for the specified intervals as X chain and the next day's data as Y chain. To get better training result, we scaled the data from 0 to 1 with min-max scalar function, and we modify the shape of the data with np.reshape. For example, if train interval is equal to 30 and the data from the October 1st to October 30 are training data, and the average USD of October 31st is the test data. And for output, we output model, predict price, real price, and figures. Secondly, here's how we design our experiment. We have variables including NFT, model type, train interval, and train columns. And we iteratively trained over around 300 models and compared models based on each variable.
And we created a web page to show our result based on JavaScript and React. Now we can take a look at the demo. And here is an interactive web page for users, and users can choose the NFT here, model, interval, and columns to see different outputs of our result.
Oh, sorry. Then here is evaluation part. We evaluation on different models. So for art blocks, we can find that the LSTM and by LSTM with attention has best performance, and like go on. And for the evaluation on different intervals by LSTM with attention, here is some result. And our conclusion is that bi-directional LSTM with interval 30 has best performance overall. And this is our future plan and the business value of our project. The next step is that it's difficult to find open source API to retrieve real-time data. So if we can have the fund, we can buy the open source API and get real-time data and put it in real world. Also, for the business value, the NFT creator and artist can understand the potential value of their work and make informed decision about how to market and sell their NFT. And NFT investors and collectors, they can better understand the demand of different type of NFT and adjust their business strategy accordingly. Thank you.